Now, one of the most important things you simply must understand when you start working on the Linux command line is the concept of parents and children. The minute you get to grips with that, you will absolutely feel more confident. So we'll have a look at what forking is, what exec is, and what return codes are, next to the concept of parents and children, of course. When you run an external command, so a command that is loaded from disk into random access memory, think of commands like ls, copy, move, etc., but also scripts that you create and run, what happens is that the shell from which you run the command will be duplicated, and then the duplicated process will be replaced with the command that you actually want to run. With that in mind, the original shell you work in is the parent, and the command that you run will be the child of that parent. And when the child starts running, the parent will simply wait for the child to die. This doesn't sound very pleasant, but it's actually what happens. If you want to know the terminology, the creation of a child process is done by the fork system call. Now don't worry about the term system call, it simply means that a user process assigns a task to the kernel. So your bash shell will ask the kernel to perform a fork, which will result in a copy of the current process. And then the replacement of the copy process with the actual program that needs to be run is done by the exec system call. And when the child is done, it will run the exit system call. In real life, it will look like this. Imagine I run the ps command. PS stands for process status. It will show me my own process, which is my shell, and the children that I have. In the first column, you see the process identifier of my shell. And we also see the PID of the ps command, which was actually the child. And when I run it again, you see that the bash shell still has the same process ID, where the ps command now has a new process ID, simply because it is a new process. The other one has died. To demonstrate that more clearly, if you run ps-f, which will give you a full listing, so more information of the same processes, we see that my shell is the parent and the ps command is the child. The child has died, and if you run the same command again, you see the parent has created a new child, which will by now be dead as well. And to make it even clearer, if you first run another bash shell and then I run the ps command, we see that the second shell is the child of the first. And the second bash is not only a child but also a parent, because I ran the ps command from the second bash shell. Now I can manually exit and it will bring me back to the parent, which was simply waiting for its child to finish. Now the coolest thing is that when the child exits, the result of that exit can be investigated by the parent. What I mean is that the child may simply have finished its job successfully and will let the parent know, or the child has run into some problems and will let the parent know of the problems. Or maybe the child simply got brutally killed. To make a long story short, there are many ways in which a child can finish or be finished. And the way for the parent to inspect that is by looking at the contents of a special variable, the question mark. This will hold the return code of the last exited child. So if you run the ps command once more and then run echo $? I see that the return code is 0. This means that the child has exited with no errors. This of course can come in very, very handy if you run scripts that start other programs, for example, so that you can test the result of the exited programs from within the script. Now if the child exits in a less pleasant manner, the return code will not be 0. Please look at the description of the video for the list of the common exit codes. Now 2 examples to end with. First, I used a cat command to try and view the contents of the etc shadow file, which holds the passwords of all users. Obviously I get a permission denied. And the return code is not 0 but 1, which actually means that there was a general error. And as a second example, I run the sleep command and let it sleep for 10 seconds. But before 10 seconds have passed, I send an interrupt by typing Ctrl+C. So this interrupts the sleep process. And now the return code is 130, which actually means that it was terminated by an interrupt. Again, I refer to the description of this video for a basic explanation of these exit codes. And finally, my question to you, what do you think will happen when I run the following command? Exec sleep 3. Exactly, as we discussed, exec replaces the current program with the new program, which is the sleep command. And after 3 seconds, it will exit, and since sleep has replaced the bash program, I'm logged out. And we're done.